So first thing I would do in something like this is graph it, see what it looks like. Zoom in on x equals 49 and see what happens. So I'm going to let that be a function in my graphing utility using Desmos today. Yeah, let's do a reset. So function notation is highly recommended. And this is a fraction. And I have the square root of x minus 7 over x minus 49. Did I type that correctly? Let's go back, make sure. Okay. And we want to see what that thing is doing when x is 49. So if we just plug in 49 to that function, the function is going to say, what? Because we get square root of 49 is 7. So I get 0 on the top, 0 on the bottom. 0 over 0 is indeterminate, which means, oh, there might be an answer. So it's just a matter of looking. So let's go change our scale here and zip out to say, let's get close. So if we go to the left side, maybe positive 48. On the right side, we'll go over to 50. And right in the middle is 49. And it looks like something's happening there. And that's pretty small. So that is somewhere between 0 and say 0.1-ish maybe. All right. So something's happening at 49, and on my scale here, it's somewhere closer to 0.07 than 0.08. So maybe it's like 0.072-ish. So we just have to pick numbers on each side of 49. And it looks like, because at 49, it looks like the left side and the right side are behaving the same. So f of 48.9999, I get 0.0714 blah, blah, blah. If we look on the other side, so f of 49.0001 would be the equivalent. On the other side, I get 0.071428, and they agree to that, about that 8 there. This one has a 6, this one has a 5 on the other side. So I've got about 6 decimal places of accuracy so far playing with this, which is more than enough for what my homework question asked for. My homework question asked me for 3 decimal places to get close to that limit. So I would say that limit is about 0.071-ish. Can I do better than that? And the answer is, in this case, it turns out I can. Here's how. I do a little funky algebra on that. When I look at that problem right there, this right here reminds me of a problem I did earlier, something like x squared minus 4 over x minus 2, right? Because I have a square and a square root involved here. 2 is the square root of 4. So this problem's similar, but it's a little bit different. So let's see, I'm just gonna do a little substitution on this right here. I'm gonna let the square root of x equal u. Now, if I square both sides of this, then I get x equals u squared, and I can rewrite this with u's. So using those 2 substitutions there, my numerator is going to be u minus 7, and my denominator is going to be u squared minus 49. And now I know that u squared minus 49 factors as u minus 7 times u plus 7. And the u minus 7 divided by u minus 7, that's 1. So that means this can be reduced to 1 over u plus 7. Now, what is u? U is really the square root of x. So my claim is that this right here is equal to the limit as x approaches 49 of 1 over the square root of x, right? Because that's what my u is here, square root of x plus 7. And now I can cheat. If I cheat and plug in 49, then I get 1 over the square root of 49 plus 7, which is 1 over 7 plus 7, or 1 over 14. Let's see what 1 over 14 is. Is it close to that value we were guessing at in the calculator? 1 divided by 14 is 0.071428, which is the number I have above, where with the original version of the function, we were just getting close to that number, but we couldn't touch it. Now we know how to touch it. What is that number? To double check, I can graph another function, g of x, and see if it does sit on top of this red one. So I'm going to graph g of x here, which is going to be 1 over, and the square root button is on the keyboard there, plus 7. And they made it red. Let's change the color. Let's make you blue. And so I can see it looks like the blue line sits on top of the red. So if I turn off the blue here, you'll see the red sitting underneath. Turn the blue back on, it looks like they're sitting right on top of each other, and they should agree on numbers. So for example, if I ask G what it thinks about 49.0001, it should give me the exact same number that I had up here. Oh, interesting. It does not. So Desmos must be having some trouble computing in there. They should be equal everywhere except 49. Okay. So probably just a calculation error there. But whereas this function was undefined at 49, G is defined at 49. And it is 1/4 there. So sometimes we can use a little bit of algebra instead of just numerically guessing at the limit. So I was able to numerically guess at the limit with my calculator, and I estimated that was 0.0179, double check, 714, I was way off. 0.0714 to 4 decimal places, but I could also say that it is 1/14 exactly. Does this function exist at 49? The answer is no, but on each side, we're approaching that 1/4 value for y.